Okay, welcome to the lesson here. We're going to be talking about finding areas of irregular shapes. So what I'll do is share my screen and we'll walk through some different problems and talk about what irregular shapes are and what some strategies are for figuring them out and for figuring out the areas of them. So let me start by sharing my screen. Okay, all right, so we'll look at some irregular shapes and let me get control of my screen here. There we go. So today, in this lesson, we're going to look at some of the basic area formulas that you may be familiar with, and we'll review how we use them. And then we're going to talk about irregular shapes, what those are, and how to take them and to turn them into area problems that you know how to solve. And you'll find, although we're only going to cover area today, the same kinds of ideas work with perimeters and volumes and other types of things too, that you can piece together and take what you know and turn these strange problems into a set of problems that you can solve. So let's look at that, and we'll start by reviewing some of our basic areas. So one of the first things that we want to look at are rectangles. And you remember that the area for rectangles, for just plain old rectangles, is just length times width. So we'll put that into practice here, and we'll try a problem with that and assume that we have a problem where a rectangle is 9 inches in length and has a width of 5 inches. So to do that, it would just be the multiplication of those two dimensions. So 9 times 5, and that's going to equal 45 square inches. And remember, when we're talking about areas, that we want our units to be square units. So what that means is if we were to take this rectangle, we could cut it up into little squares that were 1 inch on each side, and we'd have 45 of them. So if this was a big piece of paper and we cut this up, we could cut it up into 45 little 1 square inch pieces. So now let's look at triangles. And from here, we can see that the area formula for triangles is 1/2 times the base dimension times the height dimension, where this is the base right along here, and the height is the height of the triangle. So if we'll use that calculation in a real problem here, and we'll assume that this triangle has a base of 6 feet and a height of 4 feet. So we'll plug those into the equation, 1/2 the base times the height. So we have 1/2 times 6 for the base and times 4 for the height. So 1/2 times 6 times 4, which is 24. So half of 24, 12 square feet. And here, remember, square. So we use square feet since we have units of feet and we have an area. And one more review. Oh, did you have a question?
Yeah.
Okay.
Okay, so you said half the base times the height. So half of the base, because that would be 3, and then it's like basically 3 times 4, like that, or?
Yep.
I'm confused. What? Okay.
Yeah, so it's just 1/2 times the base times the height. So yeah, sometimes you hear people talking about 1/2 the base times the height. It's the same kind of thing, just 1/2 times the base times the height. Does that help?
Yes. It's just, I just don't understand it that the long way you did it. It just, I understand it better just by dividing the base and just multiplying it by the height. The other way
Yep.
is just, it confuses me.
Oh, okay. Yep. And let me show you. Let me turn on the pen here. So with this equation, there's the 1/2 the base, and then there's the height. So either way of looking at it is good.
Okay.
Let me see how I can turn off the drawing tools here. There we go. Turn it off. There we go. All right. So there's your triangle and circle. So with the circle, our area is going to be pi, that strange Greek letter there, pi, times the radius squared, or sometimes you'll see it like this, pi r squared. And you can use the approximation that pi is 3.14. Sometimes that's used for the approximation. You can extend this out to a whole lot of decimal places. In fact, it goes on forever. Or you can approximate it as 22/7. So all of those are good ways to approximate pi. But 3.14 is a good one. So for the area of a circle, the radius is the distance from the center to the outside edge of the circle. So that's from the center. Okay. And so from the center to the outside. Okay, so in this case, let's try it with a real problem. So let's say that the radius is 7 inches. So to find out the area of the circle, we have pi times the radius squared. So it's pi times 7 squared. So the area of that circle is pi 3.14. We'll substitute that in for pi. 3.14 times 7 squared. And remember that 7 squared is 7 times 7. So 7 times itself twice. So 7 times 7 is 49. So 3.14 times 49 is 153.9 square inches. Everything makes sense so far?
Yes.
Okay, all right. So I'll move on to some of the irregular shapes. So an irregular shape, when we're talking about that, it's really a shape that you don't really have a formula for. And these are kind of strange looking shapes. So to do problems that have irregular shapes, what we want to do is to turn them into a set of problems that have formulas that we know. So let me show you what I'm talking about there. So we want to turn them into things that we know the formulas for, and then sometimes we can add or we can subtract areas that we need to calculate the areas of these irregular shapes. So let's look first at this bottom one. So if we want to find the area that's in blue, one way to do that would be to find out the area of this whole rectangle, because we know the formula for that, length times width, and we could subtract off the areas of these two triangles. So that might be a way that we would approach figuring out what this area would be. Okay, so we might find the whole area and then subtract off these two areas to be left with the area that's in blue. Does that make sense?
Yes.
Okay, so for this one, we might want to use kind of a similar kind of a plan. So here we might turn this into a square, and then subtract off these two triangle areas. For this one, similar kind of a thing. We might turn this into a square, find the area of that whole square, and then subtract off the area of this small square, and then we'd be left with the area of all of the stuff in blue. And for this kind of ring-shaped thing, we might want to find the area of this circle. You know, if we knew the radius or something of this circle, we could find the area of the entire thing, and then we could find the area of the smaller circle that was inside of there and subtract that to get the area of this ring. Okay, so we're going to use that same strategy for solving 3 different problems. And one of the problems we're going to do a couple of different ways. So let's launch into that. And this might be a problem where you would want to know area. So in this case, let's say we're putting up wallpaper in a kitchen. And so that this blue area is where we want to put the wallpaper, but we have some cabinets that are hanging up into here. So we don't need wallpaper to cover that part of the wall. So the distance from the floor to the ceiling is 8 feet. And the distance across the floor here is 9 feet. And our cabinets are 3 feet tall and 5 feet wide. Okay, so we want to see what this area is, what the area of the blue part is. Okay, is that do you see what we're doing there?
Mm-hmm.
Okay, and so what might be a strategy for doing that? How could we solve that?
Well, I think just like whatever is at the bottom would be at the top, so you would track so I'm assuming that part of the blue at the top on the side of the 5 would be 4, I think.
Okay, yep, that's right. Yeah, so this would be 4, right?
Mm-hmm.
You saw that was 9, and then you saw that was 5, so that leaves 4 there, right?
Mm-hmm.
Yep.
And on the other side where it says 8, the other blue part on the bottom would be 5, but then would be 5. But then on this other side here, I think both sides would be 3. Like that part that comes down would be 3.
So that's 3 and that's 3, right?
Right, and then of course the 5 going across, like, you know, where the bottom of the cabinets, that would be 5 as well.
Yes, that's right. So this all along here would be 5, right?
Okay.
Yeah, good. So you figured out all of the missing dimensions, which is great. And we're going to use that. We're going to actually solve this problem 2 ways. And one of the ways, and you're already ahead of the game, one of the ways will be to use those dimensions that we didn't see here that you figured out. Okay? So we'll launch into that. So one of the simplest way might be to find what it would be if we had to cover this entire area, figure that out first, and then subtract the area that the cabinets would be in. Okay, so we might be able to figure out what the area of this whole big rectangle is, and then subtract off the area of the cabinets. So let's try it that way. So if we had the entire wall we didn't have any cabinets, we could calculate this area because we have a
So be
length.
8 times.
Yeah, that's right. Yeah, it would be 8 times 9. Right. So 72. Yeah. So if we were going to cover the whole wall, which we aren't, but if we were, it would be 9 times 8, or 72 square feet for the entire wall. Then we can look at just the area of the cabinets. And you're right. This 3 feet here is the same as this distance. And this 5 feet that I'm showing up here is the same as that distance. So we can figure out the area of the cabinets. So what would that be?
Well, this is the part where I'm confused, because I could just say length times the width, or I could say 2 times the length, 2 times the width. Like, I'm not sure.
Okay. Yep, and I can help you with that. So since this is an area, it's just the length times the width. So it's just 5 times 3, and that'll give you 15 square feet of area. I think what you may have been thinking with the 2 times that and the 2 times that would be the perimeter. And that's if we were to draw a line all the way around, how long would that be? So that's a different problem. What we want today is just the area. So it's just the 5 times 3. So the area of the cabinets are going to take is 5 times 3, or 15 square feet. Okay? So we can take the whole big area and subtract off the area of the cabinets. So that's what we'll do now.
So it'd be 67 square feet. Oh.
Close. 72 minus 15 would be 57 square feet of wallpaper that we would need. So 72 minus 15. Okay.
Yeah.
All right. So let's now, and you started down this road, so this is good. Since we're doing math, the kind of the beauty of math is that a lot of times you can get to the same answer different ways. So another way to do that would be, let's look at this, and let's say, rather than taking the whole area and subtracting this, let's say we just draw a line down here, and we say, okay, let's just make 2 rectangles. We'll figure out what the area of the left rectangle is, and we'll figure out the area of the right triangle. And when we're done, we just add them together, and then we've got the entire area. Okay? So as you noticed, we don't know what this dimension is, and we don't know what this dimension is. So we know that this rectangle is 8 by something, and we know that this square looking thing is 5 by something. So we want to figure out what those are, and you've done that already. So we'll do that. You notice that to find this area, we know that the dimension all along the bottom here is the same as the dimension all along the top here. And that this was 9 feet, and 5 of it was taken up by the cabinets. So that leaves 4 feet left here. So that's right, yeah, 4 feet. Okay, and then for this one, as you noticed, we have 8 feet along here. And so that would be 8 feet all the way along there, if we went all the way to the top where it would have been. So 8 feet minus this 3 feet that the cabinets were taking up means that this distance here is 8 minus 3, or 5 feet. So now we know that this rectangle on the left is 8 feet by 4 feet, and that this shape on the right is actually a square. It's 5 feet by 5 feet. So we can take those two and figure out what the area is by adding up the areas of both of these shapes. So on the left side, we had 8 by 4. So it's just a rectangle, 8 times 4. So we had 32 square feet on the left. And then on the right, we have 5 feet times 5 feet, 25 feet, 25 square feet of area on the right side. So when we add those together, 32 and 25, we have 57 square feet. So it's the same as before. So no matter how you chose to do this, you would still get the same answer. We might have even tried to draw a line across there and figure out what that was, and add up 3 different rectangles, or make this line go all the way across there, take that line off, and we'd have the area of this big triangle and this big rectangle and this little rectangle. So there's all kinds of ways that you can solve this problem, and no matter which way you choose, you should end up with the same answer, and so that would be 57 square feet. So good. We got a couple of ways to do that one. Okay, so let's go on to the next problem, unless you have questions on this one.
No.
Okay, all right, so we'll go on to the next one. Okay, so here we've got this really strange area. Okay, and we have, we want to plant grass in this green area here. And so let's say maybe this is a landscape diagram, and we might have a wall that goes across there, and maybe we've got like a food court or something, or a patio that's out here, and we've got a little bit of area left that we want to just green it up, put some grass in there. Now we want to figure out how much grass seed we need. And grass seed's kind of expensive, so we don't want to just buy a whole ton of it and hope that it works and maybe come up short or have too much left over. We want to find out exactly like how much space that we have, so we know what a reasonable amount of grass seed is that we want to buy for that. Okay, so everybody good on what the problem is?
Mm-hmm.
Okay. So let's take this and figure out how we solve it. So what do we think on that one?
I think that just by the way that it is split up, I really think that part of that is like 15 and 20 in the measurements, like say at the top where the 10 and the 20 is, but where the green starts and goes down. So I think the black area perhaps is 15, and that the other area, the green, perhaps is 20. I think.
Okay. All right. So let's figure that out. So in this particular shape, notice that we've got triangles, right? So we figure probably we're going to be using triangle formulas somewhere. And we have, notice how the entire outline here is a triangle. So you see that the entire shape, and that includes the green and the black, the entire shape is a triangle. And notice also that inside of that triangle is this black triangle. And we can figure out what the areas of both of those are, because we have all the dimensions we need. we need base dimensions, and we need height dimensions, and we've got them all. So let's look at that and figure out how we might be able to find just the area that's in the green here. So to do that, one strategy that we might do, and this is probably the easiest because it would be really hard to break this piece up into little pieces to find out, to add them all up and figure out what this area is. That would be really hard. We could do it, but it'd be hard. The easiest thing might be, okay, do you see if we take this entire area of the big triangle, and then we subtract this black area, so the area of this smaller triangle. If we do that, that's going to give us this area. Believe it or not, if we find the entire area and then subtract off the area of this black thing, that'll give us what's left. Even though it's strangely shaped, it will give us the exact answer. The green area is what we'll have left over after we subtract those two areas. So I'll take it to the first step here, and the first step will be to figure out what the whole area is. So for that, I'm going to get rid of the black, and we'll look at just the entire whole area. So if we were to plant grass in the entire thing, we're not going to do that. But if we were, we could figure out what this area is. So we know that the area is 1/2 times the base times the height, or 1/2 the base times the height. So what is the length of the base?
20.
Not 20, because we have 30 and another 10. So what would that be?
75.
Okay, so this one, it would be 30 plus 10. So it would be 40.
Oh, so you're adding it just like just doing a perimeter, like, okay.
Yeah, that's right, because what we're doing, we have to find out this length to know what the base is, what the length of the base is. And that's just a length. So that's just the 30 plus the 10. So the base is going to be 40. So what would the height of this be?
50. 30.
30, right. Yep, that's it. Okay, so let's put those into the equation. So we've got 1/2 base times the height. So we said the base is 40. We said the height is 30. And if we multiply 40 times 30, we get to 1200. So 1/2 times 1200 is 600. Okay, does that make sense?
Yes, because it's half.
That's right. Yep. Yeah. So 600 square feet. So if we were to plant grass in the entire thing, which we're not going to do, but if we were, it would be 600 square feet. Okay, so we're going to start with that number, 600, and we're going to figure out what we need to cut off from that, what we need to subtract out. Well, what we need to subtract out is this area. Okay, this was the patio. So this is concrete. So no grass here, but we have the dimensions for this one. We know that this was 30 and this was 20. Okay, so we can figure out the area of that. So we have the 1/2, we have the base of 30, and we have the height of 20. So when we multiply all those together, we get 1/2 times 30 times 20 is 600, and 1/2 of 600 is 300. So we know that this smaller triangle is 300 square feet. So now, when we look at the entire thing, we can figure out that this green area is the big triangle area minus the little triangle area. Does that make sense?
I'm not sure.
Okay. All right. Yep. So we'll go over that again. So what we want is just this green, right? We want to find out what the area of just the green is. Well, a way that we can do that using formulas that we already know, which are our triangle area formulas, we could say, what if this entire triangle was planted with grass? How much area would it have? And then how much less would it have if we took away the area of this triangle? Or another way to think of it is, let's say this was a big piece of paper and it was a triangle shape. And so we started with a triangle shape, and we knew what the area was because we knew that the length along here is 40. It's 30 plus 10. So the length along there is 40, and the height is 20 plus 10, or 30. So our piece of paper would have a certain area to it. It would be the area of the entire thing. Now let's say we took a pair of scissors and we trimmed off this part of it. So all we were left with was just this screen. Nothing down there. Well, what did we take away? We took away a triangle that was 30 feet along the one side and 20 feet along the other side. So we took all of that area away from that piece of paper, and we were left with this strip. Now, if we knew what we started with, and we knew what we took away, just like any subtraction problem, although this one's with area, but as with any subtraction problem, if we knew what we started with and we knew what we took away, then we knew what we'd be left with. So it works exactly the same way with area problems. So what we did, we figured out what this big area was, and we figured out what this little area was. And since we know we don't need to plant any grass seed in this area, we took it away. And that left us with this area. So the big triangle, we said, was 600 square feet. So that's the entire shape, 600 square feet. And the little triangle, we said, was 300 square feet. So that means that we're left with 600 minus 300, or 300 square feet. So believe it or not, if you had a lawn that was like this, there would be 300 square feet of surface that you would need to plant grass seed in. So since 1 pound of grass seed covers 100 square feet, how much grass seed do we need to cover this green area? How many pounds?
150?
Well, we have 300 square feet that we need seed for. 1 pound covers 100, So 2 pounds would cover 200.
Mhm.
So 3 pounds would cover 300. So we would need 3 pounds of grass seed to plant this area. You okay with that?
Yes.
Okay. Anything that you want me to go over on that?
No, because it kind of makes sense. Because
Okay.
if it's 300 square feet, I guess, some of it's just, like I said, just trying to comprehend certain things, or, sometimes you can read things, but it's not processing.
Yeah.
But for 1 pound of grass and 100 square feet, and it clearly says it's 300 square feet, then yeah, it definitely makes sense.
Okay.
I'm
Okay.
just I'm sleepy, so.
Yeah, no, that's okay. It's Monday too. Okay. All right. So we'll go on to one other problem, and we'll see how we might solve this one. So we know that we have 1 gallon of paint, and that gallon of paint can cover 350 square feet. So what we want to do is we want to paint the area on a basketball court that is the entire free throw lane. So first of all, imagine this is a basketball hoop right here, right at the bottom. And you've got the free throw line goes across. And then we've got the 2 sides of the lane. And this entire lane goes a little bit behind the basket. Okay. And then there's also that circle that's around the free throw line. So with the real dimensions on a real basketball court, the distance from the free throw line to the end of the court is 19 feet. And the radius, remember that radius is the distance from the center of the circle to the outside of the circle. The radius is 6 feet. And that's on an actual basketball court. And just for future reference, because we're going to need to know this, notice that the circle goes just to the edge of the free throw line. Then it goes all the way around and just to the edge of the free throw line. So since this is the radius from the center of the free throw line, we're going to know that this distance would be what? This is the radius. Radius is 6 feet. So the distance from the center of the free throw line to the edge is also 6 feet. Because this radius, all of the distances from that center point to everything on the outside edge, since that's a radius, all of those distances are exactly 6 feet. So it's 6 feet from the center to the outside of the free throw line, so that's 6 feet. And it's also 6 feet from the center to the other outside part of the free throw line. So that's also 6 feet. So that's going to come in handy to know that in just a moment.
I think I'm confusing the radius with the diameter.
Ah, yeah, okay. Yeah, the diameter is the distance all the way across the circle. And that's 2 times the radius. So the radius is just from the center to the outside. So that's only halfway across the circle. So it's 6 feet there, and it's 6 feet there. So the entire length of this free throw line would be what?
And I'm confused. I did it squared.
Ah, okay. Yeah. So with this circle, what you described as the diameter, okay, the distance all the way across, that's actually what the length of this free throw line is. See how that goes all the way across the circle?
So it's 12.
Yeah, right. Good, good. So it's 12. Yeah, so now we know a bunch of dimensions. We now know this rectangle area is 19 feet long and 12 feet wide. And we also know that we're going to have paint in this part too. So we've got paint in this rectangle, and we've got paint in this half circle. Okay? So the areas that we want to look at are the areas of this rectangle and the area of this half circle. And when we find out both of those, all we need to do are just add them together, because we've got this area plus this area, and that'll tell us how much paint we need. And then when we figure out how much paint we need, we can see if it's less than 350 square feet. Okay, with me so far?
No.
Is that a no?
Because I turn around. I don't know why I keep getting confused. But I multiplied the 19 and the 12. Like, see, I don't know, I guess I keep reaching a point where I'm not sure when to correctly use the formula. Whatever
Okay.
the formula. You know what I'm saying? Like,
Yeah, and that's good, and we'll actually do that. So you'll see, and you're definitely on the right track. So let's work it out. We'll work it out step by step, because this is a multi-step problem. So what we want to do is we want to find the area of this rectangle, which you've already done, 19 times 12. And then we want to add to that the remainder here, which is the half circle that sits on top of this rectangle. Okay, so let's do that. So first of all, and we've already figured this out, the width of the rectangle, because we know that it's 6 feet for this radius plus 6 feet for that radius. So it's 12 feet across, which we've already figured out. And then we want to find the area of half a circle. So how do we find the area of half a circle? We know the formula for a circle. So how do we figure out what the area of half a circle is?
we subtract it,
Kind of.
divide.
Yeah, that's better. Yeah, we divide it by 2. So first what we'll do is, and we'll get to this eventually, but we'll find the area of the entire circle, and then we'll just divide it by 2, and that gives us the area of half a circle. Okay, all right, so first we're figuring out the area of the rectangle. So we'll check your work here, and so we said that that was a radius there, was a radius of 6 feet there. So the length of that free throw line is 12 feet, which we've already figured out. So that means to find the rectangle area, and we'll see how this checks with what you had, 19 times 12, length times width. So that's 228 square feet. Does that sound right? Okay,
Yep.
good. Okay. All right, so the area of this rectangle, which is only part of what we have to paint, is 228 square feet. So we're partway there. Now we still have to figure out the area of the circle, and actually the area of the half circle. And as we said, we'll do that by finding the area of the whole circle, and then we divide it in half. Okay, so now it's just a circle problem. So remember that the area of the whole circle is pi times the radius squared, where pi is 3.14. So we'll start plugging in some numbers for that, and we'll figure out what the area of that whole circle is. So when we do that, we know that the radius is 6 feet. So we have pi, which is the 3.14, times the radius squared. So it's pi times 6, or pi times 36, because the radius is 6, and 6 squared is 36. Or 6, sometimes you would say 6 to the second power. Both of those are the same, but usually for the second power, we always say squared. Okay, so if we were to multiply 3.14 times 36, and then round it to 1 decimal place, we end up with 113 square feet. And that's for the whole circle. But we really only have to paint this half circle, since this stuff is already in that big rectangle that we already figured out. So we just have a half circle. So half of 113 is 56.5, or 56.5 square feet. So now we know all we need to know to figure out how much area that we have to paint. So now we can take the area of this rectangle and add it to the area of the half circle. So let's do that, and we'll figure out how many square feet we have to cover with that paint. Okay, so the half circle, 228. I'm sorry, the rectangle, 228 square feet. The half circle was 56.5. So since we want to find this total area, we're going to add them together. So when we add them together, 284.5 square feet. So we make it, we do it, because that's less than 350. So our whole gallon can will be enough to paint this entire basketball key. Now, if we assume we've got 2 basketball keys on each court, then we probably need almost 2 gallons. But our 1 gallon will be enough to do 1. Okay?
Wow. I miscalculated somewhere though. I don't know what it is. Like I have to really, it was like, I don't know, I can't calculate fast because I would get lost. I know you can't press my chicken scratch, but.
Yeah, and that's okay. And I was kind of cheating because I did all these ahead of time. So I have all these calculations here. But yeah, if you want to review the video, because it'll be recorded and it'll be online. If you want to review it sometime, and then you can pause it and work out your calculations and see if they agree with what we figured out here. So just to kind of touch on things, just to summarize. So we know how to calculate the areas of a lot of different shapes because we have formulas for doing that. But when we have these irregular shapes, we have to turn them into different problems that we know how to do. So sometimes we have to cut things up into sections. Sometimes we have to look at what is not part of the shape and subtract that from something that would be a part of the shape if it was there. And sometimes we have to add, different things together to lump them together. So we did a little bit of all of that in this lesson today. And you just sometimes have to stare at it a little bit. And it just takes a little creativity to kind of figure out how you could make it into shapes that you can do the calculations for. Now you'll find that this will work as I mentioned at the beginning, this will work with sometimes if you're figuring out perimeters. So like, this morning in a session, we looked at the length around a track and how far it was to run around the track. And since it's a distance around something, that was a perimeter. So we did that by forming some different shapes. We made a rectangle in the middle part, and we had 2 half circles on either end. So we used circumference and perimeter formulas to piece together what the length of that would be. So this is just kind of a general sort of trick that you could use to piece things together if there are strange shapes. You can do it with volumes too. So if we had a water tank that had a bottom that was like half a sphere, and then a lot of the tank was a cylinder, we could calculate both of those and figure out what the volume of a tank was. So in this lesson, we just focused on area, but you can use it for other shapes and other types of calculations. So, do you have? Let me put it back on. Oops, take that off there. Are there any other questions that you have that we can cover?
No, I think I know for a fact that I'm going to try to like really practice, because I noticed that is a weak area for me. And I need to probably more like, like maybe just the rest of this week. I'm still logging on the classes, but I'm just saying the rest of the week, I need to try to memorize the formulas because I'm confused when to use them. It seems like.
Mm-hmm. And that just takes practice. Yeah. And they'll kind of come more into place as you get a little bit more familiar with the problems. Because you were trying to, take a pretty big jump today in going from the regular shapes to the irregular shapes. So, and you're catching on. So,
I'm
and
trying.
it just takes a little bit of practice, and actually it takes a lot of practice and just repetition and going over the problems, to become a little bit more familiar with it. But you're on your way.
It was still an awesome class either way, And like I said, I tried to like take my little notes
Mm-hmm.
just to try to remember some of what you were saying. And like I said, I really have to just focus on a way to try to remember the rules and when to use them, because that's where I got confused that with the diameter and the radius, because I couldn't remember, and then on other problems where it did require it to be like a multiple of itself, like I couldn't tell when to and when not to. So I know this is a weak area for me.
Mm-hmm. Yeah, and after you've had a chance to work on it a little bit, and like remembering that diameter is twice the radius, and things like that. And after you've had a chance to work on some other problems, you may want to come back to this video and try them. Just pause the video, look at the problem, pause the video, try to figure it out. And then if you get stuck, you can replay the section or whatever, or you can always check in with tutors too in the live sessions, during the day too, to work things out and to explain, things to you. But yeah, hopefully this was helpful.
It was very helpful. I can say that I'm further along than I ever was in a regular brick and mortar Scouts honor. So I'm picking up something. You guys are doing something right, so it's just a matter of knowing when and when not to, and memorizing, and it's like I have to I have to figure out a way to kind of like keep my focus, because that's another issue that I have. I have quite a few, like like I said, sometimes if I'm looking at something too long, not something, but like numbers or like words, and I start to like scramble, and then and then my eyes get tired, and then I'm like struggling trying to stay awake,
I
so it's
totally
like
get that.
I'm fighting things here.
Yeah, I totally get that.
Yeah.
Same thing happens to me.
Okay. Well, wow, I can't believe that hour went by that fast.
Time flies when you guys are having fun, right?
Yeah, that's right.
Well, it's always good when like I said, when you have, I don't even want to call him a tutor, I'd rather call him a teacher, because that's what's being done, this is teaching. So I think when you have a person that's a good teacher, it doesn't make things drag. He's engaging, and that's helpful too.
Oh, well, that's good to hear.
Yeah.
Yeah, well,
So
thank you.
oh, you're welcome. No, thank you, and thanks, Seeds. So so I'm gonna wait. I'm gonna log off. I'm gonna wait. I gotta check and see when's the next math one, because I don't think I'm gonna do the reading today, because I'm like struggling, like just like staying focused. So I know I need to take a break. I'm not like really sleepy. It's just, I mean, I got like a diagnosis, and it's like if I'm doing something too long, then it affects me a certain way, and then I'm starting to lose focus, and I don't want to do that.
Mm-hmm. It makes sense. Sometimes it makes sense to walk away for a little bit.
Yeah. So I'm gonna try to come back. I think it's another one. I think maybe at 6. I don't know. I have to look at the thing. I do believe it's another one though at 6, or even if it's a math one, a table math or something at 6. So I'm gonna try to do that. Maybe I'll like take me like a little mini nap or something, just to try to rest my eyes, because I'm like, if I'm just looking at it too long, and it's just, I can't focus. Focus. Yeah. So I'm
Yeah.
gonna log off, and thank you too.
All right.
Take care.